Right, 9.2, proofs using coordinate geometry. So example 1, how can you use coordinates to prove geometric relationships algebraically? We want to plan a proof for the trapezoid midsegment theorem. So a reminder that our trapezoid midsegment theorem is that the midsegment of a trapezoid is parallel to each base and its length is 1/2 the sum of the length of the bases. So the first thing we want to do is create a sketch for our trapezoid. Okay, so then I'm going to label these so I know that this first point here, I'm going to label it A, and it's on the origin, so it would be at 0, 0. I'll name this one B. Connect these. Okay, so B would be at points A, B, C, it's going to have the same y value but a different x value. So my x I'm going to name as C, but my y value is the same as the y from B. So it's just this B. And then finally D, my x value has a different x value than A. So I'll just call that D, but my y value for D is the same as A, so it will be 0. Okay, so the first thing we want to do in creating our proof is to restate the theorem. Okay, so I'm going to restate this. So if EF is the midsegment of our trapezoid, A, B, C, D, then my slope for EF is equal to the slope of BC. Okay, and I can put my E and F on here. So E and F. So that means my slope, EF, would be equal to the slope for BC. And that my equation for EF is that it would equal A and D, my base, plus my top, BC, added together and divided by 2. Okay, so to prove this, I would have 2 steps. The first is that I would need to prove that the midsegment is parallel to the bases if my slopes are equal. So I would need to prove that the slopes are equal. All right, the second thing I would need to do is show that the mean of the base length is the length of the midsegment. All right, so I would have to basically show that the average, if I add my bases together, it's going to equal, add them together and divide them in half, it's going to equal that midsegment. Okay, let's look at the try it. All right, we want to plan a proof to show that the diagonals of a square are congruent and perpendicular. All right, so first we're going to sketch out a square here. Again, do the best we can. It won't be perfect. I'm going to label these points. Okay, I know that A is on the origin, so it's 0, 0. B, my x value, I'm just going to name A. My y is still on 0. C, my x value is the same as the B's x, so it's A. And because this is a square, we are traveling the same distance, both x and y. So that means my y would also be A. And then finally D, again, because it's a square, my y would be the same. We're traveling the same distance, so my y would be that A as well. My x is still 0. All right, so then to plan our proof, the first thing we would want to do is to use our distance formula to find the length of the diagonals and show that they're equal to each other. So our diagonals, we would want to try to prove that those diagonals are congruent and equal to each other. So we would use the distance formula to prove that. Okay, second thing that I would want to do is we would want to find the slope of the diagonals to show that they are negative reciprocals and that they are forming 90-degree angles. All right, example 2. We want to write a coordinate proof for the trapezoid mid-segment theorem. All right, so we kind of started pre-planning this in example 1. So the first thing that we would want to do is prove that our slopes are equal to each other of that mid-segment. So the first thing I have to do is actually find these points to prove that my slopes are equal to each other. So first thing I need to do is find the coordinates for E and F. So I'm going to use my midpoint formula to find those coordinates. Okay, so using my midpoint formula, I'm going to find the coordinate for E. So my coordinate for E is going to give me A over 2 and B over 2. Next, I want to find the coordinate for F. So that will get me I'm going to switch these around, C plus D. over 2, and then b over 2. Go ahead and label these. I'll label my e. Okay, so we found our midpoints. Now we want to use those midpoints to find our slope. And we're trying to prove that EF, AD, and BC are all parallel to each other, so they all need to have the same slope. Okay, so we want to find the slope for those 3 sides. Oh, no, hold on, let me start this over. It's using the wrong point. Okay, EF. Okay, so the b over 2 minus b over 2 on the top is going to give me 0. And then I end up with, okay, anything with 0 on top is just 0. So my slope for EF is 0. Let's do AD next. Zero minus 0, 0 minus d. So I get 0 on top, negative d on the bottom, which is just 0. And then we will check BC. Okay, again, I've got 0 on top, so this is just 0. So all of my slopes are 0. They are all equal to each other. My next step is to find the lengths of AD, BC, and EF. So the bases and that mid segment. Okay. All right, so to find our lengths on these, it's pretty easy because we just have horizontal segments. So my length for AD, I take my x's and subtract, so d minus 0. So my length for AD is d. BC, I take c and subtract a. C and subtract a, so my length is just the c minus a. And then EF, I will take my x coordinate, so c plus d over 2, and subtract a over 2. That will simplify to c plus d minus a over 2. Okay, so those are my lengths. Now I want to show that EF equals the two bases divided by 2. All right, so to do that, we're going to take the links that we just came up with above and plug those in. So we're going to take, so our EF will equal AD. Well, AD is AD we found to be D. And then to that, we will add our BC, which our BC is the C minus A. And then we divide that whole thing by 2. And if it helps to keep things more separated, we can put those into parentheses. Then when I simplify, I'll get the same thing. Okay, I can rearrange this. Actually, let me back up and I'll do that. So I'm going to rearrange this. So C plus D minus A over 2. So this is the same as this, and both of those are EF. So we were able to prove that those were equal. So our EF, we were able to prove that it's parallel to AD, it's parallel to BC, and we were also able to prove that EF is equal to AD plus BC divided by 2. Okay, let's look at the try it. Use coordinate geometry to prove that the diagonals of a rectangle are congruent. All right, so very similar to the square that we had come up with above, but this time it's a rectangle. So again, our A is on 0, 0. Go ahead and connect these. B will be at A, 0. C is at A, B. And then D is at 0, B. Okay, so very similar to the example 1 try it that we did. Our first step on that was to identify the diagonal links. So we're going to use the distance formula to find our diagonal links. So my diagonal would be AC. Use the distance formula to find those links. Okay, that's going to simplify to the square root of A squared plus B squared. And then I want to find my diagonal for BD. And then one will simplify to A squared plus B squared as well. So we've proven that our two diagonals are congruent, that they have the same lengths. All right, example 3, we want to write a coordinate proof of the concurrency of medians theorem. And we are given that triangle ABC has medians AD, BE, and CF. We need to prove that the medians are concurrent. Okay, so the first thing we want to do is we want to sketch this out. And we're creating a triangle. Okay, and it's triangle ABC, so A is at 0, 0. B would be 2A, 2B, because we're going to have our medians in there, our midpoints in there. And then C would be at 2C and 0. All right, so then our midpoints, F and D, and then E. Okay, so the first thing we would want to do is find our coordinates of those midpoints. Okay. So to find my midpoint of D, I would have 2A plus 2C divided by 2, and then 2B plus 0 divided by 2. So my midpoint for D is going to end up being A plus C. Let me write that a little bigger. A plus C. And then my midpoint or my Y is just going to be B. Okay, E. All right, so my midpoint for E is going to be C and 0. Then finally F. So my midpoint for F is going to be A and B. All right, so we found our midpoints. Now we want to find the slopes for AD and CF. Okay, my slope for AD, B minus 0 over A plus C minus 0. So that's going to simplify down to B over A plus C. My slope for CF is B minus 0 over A minus 2C. So that will simplify to B over A minus 2C. So I have my two slopes. Next, I want to write an equation for those two bisectors, medians. right, so we're going to use our point slope formula. So y minus 0 equals b over a plus c. Times x minus 0. So that is going to simplify to y equals b x over a plus c. All right, our second equation, y minus 0 equals b over a minus 2c times x minus 2c. That will simplify to y equals bx over a minus 2c minus 2bc over a minus 2c. Okay, so I have my two equations of the line. Now I want to solve for x. Okay, so both of these y's are the same y's, so I can substitute one y into the other equation. So I'm going to set both of those equal to each other. So I would have bx over a plus c equals bx over a minus 2c minus 2bc over a minus 2c. Okay, once I simplify that, I'm going to end up with x equals 2a plus c over 3. All right, so now we want to substitute x into one of our two equations. It doesn't matter which one. I'm going to go with the smaller equation. Okay, so I'm going to substitute in that x. So y equals b 2a plus c over 3 over a plus c. That's going to simplify and give me y equals 2b over 3. Okay, so I have my x and my y values for where those are intersecting. So let me change my color here. So I've got this median and this median, and I just found the point where they are intersecting. So my point P, where they intersect, our x value that we found was the 2a plus c over 3, and the y value we just found was 2b over 3. Okay, that is that point P. All right, so next we want to prove that point P lies on the other median BE. So we need to write its equation. Okay, so we want to write its equation. The first thing we need to do is find the slope for BE. All right, so we have the slope for BE. Now we want to write the equation, so we're going to use point slope form. So y minus the point we just found for our y, so 2b over 3 equals the slope for this BE, the negative 2b over c minus 2a times x minus our x point for b or p, so this x point, and we used our y point here. A plus c over 3. Alright, so that will end up simplifying and giving me y equals negative 2bx over c minus 2a plus 2bc over c minus 2a. Alright, so now we want to solve for x. And we're going to plug in our x value from p from above, so y equals negative 2b, and then the x from above. Okay, from here I can simplify and I will get y equals 2b over 3, which is my y value, so that means that p is on B. And that all 3 of the medians are concurrent at P. Okay, let's look at the try it. Gonna have to erase some of this so that we got some more room. All right, so for our try it, we need to complete the proof of the concurrency of medians theorem. We want to use the distance formula to show that AP is 2/3 of AD, and that BP is 2/3 of BE, and that CP is 2/3 of CF. All right, so in the example, we were able to find the points for these medians. So F is A, B, D is A plus C, and then B, and then E is C and 0. Okay, and then we also found this point P. Okay, so we've got all of those labeled. First thing we want to do is find the length of AP. So we're going to use the distance formula to find the length of AP. Okay, so that's going to simplify to eliminate those zeros. All right, next we want to find the length of AD. So that will end up simplifying. Next we want to find, all right, so we're trying to prove that AP is 2/3 of AD. Right now AP is kind of hard to look at, so we're going to simplify that. So I'm going to come down here with this and work on simplifying that AP. So I'm going to take the square 2 squared, I will get 4. And then the 3 squared that's on the bottom, I would get 9. We'll do the same thing to the second one. So 2 squared, I will get 4. 3 squared, I will get 9. All right, I'm going to pull, each of these components has a 4/9, so I'm going to pull those out to help keep simplifying this. But I lost my square, so each of those would still be squared. So the only thing I squared was the 2 and the 3 that was on top and bottom. All right, so now I'm going to take the square root of the 4 and the 9. So once I bring those out, then inside, oh, that's not what I wanted. All right, so now if I look at this AP compared to the AD, I can see that my AP is 2/3 times the entire AD. Okay, so it is true that AD and AP are true. So AP is 2/3 of AD. That is true. If I wanted to create the other 2, I could create those pretty easily. So BP would be equal to 2/3 the square root C minus 2A squared plus 4B squared, which is 2/3 of B. Similarly, if I wanted to create my CP, I can do that. So 2/3 of the square root of 2C minus A squared plus B squared equals 2/3 of that CF. Okay, example 4, we want to use coordinate proofs to solve the problem. An interior designer wants the center of a circular fountain to be equidistant from sides of a triangle lobby. Where should he place the center of the fountain? So we want to place the center of the fountain in the very center of this triangle so that it is equidistant from all of the sides of the triangle. Okay, so we want to be able to find the circumcenter of the triangle because that is the center of the triangle. All right, to find that circumcenter, we need to find all of the midpoints. All right, so we're going to find the midpoint of each of the sides. So if I go ahead and, oh, that is definitely not close to the center, we'll just kind of create little centers on here and label them. Okay, so then to find my midpoint for each of these, E to find my midpoint. That should be plus. So my midpoint for E is C over 2 and 0. My midpoint for F would be C plus A over 2 and then B squared. So G is A over 2 and B over 2. Okay, so next we're going to create the equation for the perpendicular bisector of AC. So we are writing an equation for this perpendicular bisector here that forms a 90-degree angle. Okay, and if our point E here is C over 2, 0, that means the equation for this perpendicular bisector would be x equals C over 2, because we are creating a vertical line straight up and down. Okay, and then our perpendicular bisector for AB, right here, our point G, those coordinates are 2. Okay, so we want to find the perpendicular slope of AB. So that we can find that bisector slope. So I want to find the slope of AB and then make the negative reciprocal of that. So AB okay, so my slope for AB is B over A. The perpendicular slope then is the negative reciprocal. My negative reciprocal would be negative A over B. Okay, so now we want to create an equation of the line. So y minus, we're going to use our points for G, that's the midpoint of AB. So y minus b over 2 equals that perpendicular slope, negative a over b, times x minus a over 2. Okay, so I'm using this point into my point slope formula. I'm going to simplify. All right, so now we are going to substitute in our x value for our perpendicular bisector for BE, which we already identified as this x equals c over 2. So we're going to plug in that c over 2 in for x. That will end up simplifying and giving me a squared minus AC plus B squared all over 2B. Okay, so I'm able to find the center of the fountain based off of that x coordinate, and then what I just found for this y coordinate. So my center of my fountain is at coordinates c over 2 and a squared minus ac plus b squared all over 2b. All right, let's look at the try it. A table has a top that is a right triangle and a single support leg. Where should the center of the leg be placed so it corresponds with the center of gravity of the tabletop? We need to plan a coordinate geometry proof to find the location. We don't actually have to find the location, but we need to plan it. All right, so the first thing we want to do is sketch it out so that we can find the centroid. Okay, in my right triangle table, my A coordinate, my B, and my C, and then my bisectors. So the next step in this proof would be to use the equation of a line to create an equation for two of the medians to find out where they intersect. So I would be creating an equation for two of the medians, didn't matter which two, so that I can find out where they intersect. Okay, after I have done that and I found their intersections, that intersection is the centroid.